Assalamualaikum. My name is Aina Suhailah binti Muhammad. Matrix number M112320013. My main supervisor is IR Dr. Mak Paliza binti Azri. My co-supervisor is Dr. Wahida binti ABD Halim. So the title of my research is Optimized Topology and Switching Strategies for Minimizing Leakage Current in Single-Phase Transformerless Inverter PV System. So this is the table of contents for this slide presentation. First, the problem statement of my research is that despite the implementation of the inverter design with the transformer, this leads to the low power conversion efficiency less than 95%. Thus, recently, the PV grade transformerless inverter technology is introduced by many researchers due to their higher efficiency. The absence of a transformer in inverter PV system does create large leakage current, which is higher than 300 mA due to higher common mode voltage, which will injure the person when touching PV panel. Regarding the VDE 0126-1-1 standard, the limitation of leakage current is not larger than 300 mA. The modulation switching technique, inverter topologies and filter designs are factors affect the reduction of ground leakage current in transformerless inverter PV system. The research objective is 1. To design and analyze the factors contribute towards leakage current, which are switching strategies, inverter topologies, and filter design in single-phase transformerless voltage source inverter for grid-connected system. Second, to evaluate the performance between H4 bipolar PWM, H4 unipolar PWM, H5 and H5D in terms of THD load current, leakage current, and power conversion efficiency. And lastly, to evaluate the performance of power semiconductor devices between IGBT, MOSFET, and SiC in terms of leakage current and power conversion efficiency. Next, research scopes. The aim of this project is to focus the performance of single-phase transformerless inverter on reducing ground leakage current less than 300 mA based on German standard and comply with IEEE standard 519, which is total harmonic distortion of output current is below than 5%. Next, several single-phase transformerless inverter technologies are simulated and validated through experimentation to identify the factors influencing ground leakage current, including switching strategies and filter designs. Next, several types of semiconductor devices, including MOSFETs, IGBTs, and SiCs, are examined to increase the efficiency of single-phase transformerless inverter. Lastly, unfortunately, the limitation of the project is that the grid is modeled by R load. Next is the literature review. So, in terms of renewable energy sources, there is wind energy, solar energy, and biomass energy. Between these three renewable energies, for this research, I choose solar energy because the advantage is reduces the dependency on conventional energy sources and saves from growing electricity costs. But there's still a bit of disadvantage, which is the initial installation price is still a bit expensive to some people. Next, in terms of transformer or transformerless inverter, for this research, transformerless inverter is chosen because the advantage which gives higher efficiency reduces weight and costs. But the disadvantage of using transformerless inverter is that it does not have isolation between DC and AC part, thus creates large leakage current. Next, for inverter topologies, there is three: H-bridge, DC decoupling, and AC decoupling. For DC decoupling, such as H5 or clamp H5. For AC decoupling, such as Herix. So for this research, H-bridge and DC decoupling is used because for H-bridge, it is the basic structure of inverter topology, but its disadvantage is less efficient. For the DC decoupling, it advantages lower number of switches, thus lower switching and conduction losses. For pulse width modulation technique, both bipolar PWM and unipolar PWM is used because for bipolar, it gives lower leakage current and constant common mode voltage, while unipolar gives higher output voltage level and higher efficient than bipolar PWM. Next, for filters L, LC and LCL, three of these are simulated to see which is the best in reducing leakage current. And lastly, for power semiconductor devices, three of these, IGBT, MOSFET and SiC, is also compared to see which can give lower leakage current and higher efficiency. Next, for the expected outcome, after this research is completed, the following contribution will be accomplished. Single phase transformer inverter PV system is designed. Factors that contribute towards leakage current, which are switching strategies, inverter topologies, and filter design are analyzed. In terms of switching strategies, bipolar PWM gives lower leakage current than unipolar PWM. In terms of inverter topologies, H5D and H5 bipolar PWM gives the lowest leakage current due to having stable common mode voltage. And lastly, in terms of filter design, LCL gives lower leakage current than L and LC filter. The common mode equivalent model, which contributes the ground leakage current in the PV transformer system, will be identified. The performance analysis between H4 bipolar PWM, H4 unipolar PWM, H5 and H5D in terms of total harmonic distortion, load current, leakage current and power conversion efficiency are evaluated. In terms of the HD load current, only H4 bipolar PWM, H5 and H5D complies the THD current standard below 5%. In terms of leakage current, H5D and H4 bipolar PWM gives the lowest leakage current due to having stable common mode voltage. And lastly, in terms of power conversion efficiency, H5D produces the highest efficiency compared to H4 bipolar PWM, H4 unipolar PWM, and H5. The performance analysis of power semiconductor devices between IGBTs, MOSFETs, and SiCs in terms of leakage current and power conversion efficiency are evaluated. SiC produces the highest power conversion efficiency compared to IGBT and MOSFET. So this is the milestone and timeline for completion of this research. And lastly, for conclusion, in conclusion, single-phase transformerless inverter have emerged as a viable and efficient solution for converting DC to AC power in various applications, particularly in solar photovoltaic systems. These inverters offer several advantages, including higher efficiency, reduced size and weight, and lower cost compared to traditional transformer-based inverters. However, various issues and challenges related with single-phase transformerless inverter must be addressed. The lack of galvanic isolation in transformerless design raises concerns about ground fault protection and potential leakage currents. Adequate safety precautions as well as compliance with electrical regulation and standards must be established. Additionally, the needs of the application should be carefully considered while selecting single-phase transformerless inverters. Transformer-based inverters have benefits in some cases, although they may still be better when galvanic isolation is a major factor or when using them is required by particular grid specification. In the end, single-phase transformerless inverters are a promising technology for increasing the efficiency and cost-effectiveness of solar power systems. However, for success, careful preparation, respect to safety standards, and a full understanding on the application requirements are required. Lastly, these are the references for this slide presentation. That's all from me. Thank you.